Yesterday, Joe Rogan released his interview with Avi Loeb, and the timing could not be more perfect. Today is October 29th, 2025, and right now, at this very moment, 3i Atlas is making its closest approach to the Sun. Perihelion, the moment we have been waiting for. And in that conversation, buried between discussions about the Fermi Paradox and Arthur C. Clarke novels, Avi laid out details about 3i Atlas that most people might have missed. Details that reveal just how strange this object really is. Because when you listen carefully to what he is actually saying about the anti-tail, the nickel emissions, the spherical shape, you realise the scientific community has been wrestling with something genuinely anomalous for months. Something that does not fit our models. Something that challenges our assumptions about what interstellar objects should look like. If you're finding value in this deep dive analysis, gently tap that like button and subscribe to stay updated, and tell me in the comments where you're listening from, what time it is there, and what you think is the most compelling anomaly about 3i Atlas. Want to help our community grow? Share this on social media and hit that new hype button. Thank you for all your support. Let me take you back to July and August of this year, when astronomers around the world were watching 3i ATLAS approach our solar system. They were taking images, running spectroscopic analysis, doing everything scientists do when a massive interstellar object enters our cosmic neighbourhood. And that is when they saw it. Something that should not exist. Something that violates the basic principles of physics as we understand them. 3i Atlas had an anti-tail. Now before your mind glazes over thinking this is just technical jargon, let me explain why this is absolutely mind-bending. When a comet approaches the Sun, it heats up. Ice turns to gas. Dust particles get released. And here is the critical part, those dust particles, typically about half a micrometer in size, roughly the wavelength of visible light, they scatter sunlight incredibly effectively. The Sun is not just a big ball of light. It is a cosmic wind machine, constantly pushing outward with radiation pressure. When those dust particles get hit by sunlight, they get pushed. They get pushed away from the Sun. Always away. This is not a theory, this is observed fact. Every single comet we have ever studied, and we are talking about hundreds of them, shows this exact same behaviour. The dust trails behind the comet, away from the Sun, creating that classic tail that everyone associates with comets. But 3i Atlas did the opposite. During July and August, as it approached the Sun, material was flowing toward the Sun. Not away, toward. Like watching a video of a waterfall flowing upward. Like seeing smoke drift down instead of up. It is the kind of thing that makes you question whether you are looking at the data correctly, whether there is some mistake in the image processing, whether your telescope is broken. But it was not broken. Multiple observatories confirmed it. The anti-tail was real. Avi Loeb in that interview, he did not sensationalize this. He stated it as fact. Matter of fact. Almost too casually. But you could hear in his voice, if you listen carefully, that this is the thing that keeps him up at night. Because when Joe asked him about it, when Joe pushed him on whether this could just be a natural phenomenon, Avi did not give the usual scientist hedge. He did not say, well, we need more data. He said this is very unusual. Think about what this means for a moment. Imagine you are driving down the highway, and you see a car driving backward at 70 miles per hour. Not just rolling backward, but actively accelerating in reverse. Engine running, going the wrong way. Your first thought would not be, oh, maybe the transmission is acting up. Your first thought would be, something fundamentally different is happening here. Either the driver is doing this intentionally, or the laws of physics in that location have somehow changed. There is no middle ground. The anti-tail of 3i Atlas is that car. Now, the mainstream explanation, the one that lets scientists sleep at night, is that maybe there is some quirk of geometry. Maybe we are viewing the object from a weird angle. Maybe there is some optical illusion happening. Maybe the dust is being released in bursts and we are seeing some complex interaction of different particle sizes and radiation pressure and orbital mechanics. And sure, maybe. But here is what Avi pointed out and what makes this explanation fall apart under scrutiny. If this was just geometry, if this was just viewing angle, we would see this all the time. We have observed hundreds of comets from every possible angle. We have sent spacecraft to comets. We have analysed them up close. Not once, not ever, have we seen an anti-tail that persists for months. but we see this all the time. We have observed hundreds of comets from every possible angle. We have sent spacecraft to comets. We have analysed them up close. Not once, not ever, have we seen an anti-tail that persists for months. But wait, it gets stranger. In September, something changed. The anti-tail disappeared, or rather, it reversed. 3I Atlas suddenly started behaving normally, developing a regular tail pointing away from the sun like a good little comet should. Except, and Avi emphasised this in the interview, even that normal tail is weird. It is too small. Way too small. Other comets at similar distances from the sun, with similar brightness, they have massive tails stretching millions of kilometres. 3I Atlas barely has a tail at all. So let me get this straight. For 2 months, impossible behaviour. Then suddenly, normal behaviour, but not quite normal enough. This is not how nature works. Nature is consistent, physics is consistent. If you are a chunk of ice and rock tumbling through space, you do not get to choose when to follow the laws of physics and when to break them. Unless you're not just a chunk of ice and rock. Joe Rogan, to his credit, he caught this. He pushed back. He said, look, maybe this is just natural. Maybe we do not understand comets as well as we think. And Avi's response was fascinating. He did not disagree. He said, yes, it could be natural. We need to figure out why it is so unusual. But then he pivoted to something that I think most people listening to that podcast missed. He talked about how we have observed hundreds of comets, but only 2 confirmed interstellar objects, Oumuamua and Borisov, and now 3I Atlas makes 3. 3 data points. That is all we have for objects coming from outside our solar system. 3, and 2 of them, Oumuamua, and 3I Atlas, are wildly anomalous. Oumuamua, with its acceleration without visible outgassing, its bizarre elongated shape, its tumbling motion, and now 3I Atlas with its anti-tail, its nickel emissions, its near spherical shape. Only Borisov looked normal. 1 out of 3. If I told you that 1 out of every 3 cars you see on the highway is driving backward, would you conclude that our understanding of cars is wrong? Or would you conclude that something very different is happening? The anti-tail mystery is not just about dust particles flowing the wrong direction. It is about what that implies. Because there are really only a few possibilities here, and none of them are comfortable. Possibility 1. Our understanding of radiation pressure and comet behaviour is fundamentally wrong. Decades of planetary science, thousands of observations, all of it somehow missing a basic principle. That seems unlikely. Possibility 2. 3I Atlas has some exotic composition that we have never encountered before. Something that interacts with sunlight in ways we have never seen. That is possible, but then we have to ask why interstellar objects would have such exotic compositions. What are they made of that our local comets are not? Possibility 3, and this is the one that Avi dances around without saying directly, the behaviour is not passive. It is active. Active outgassing, active manoeuvring, active control. Now, I'm not saying 3I Atlas is a spacecraft. I am saying that the data, the actual observations, the anti-tail that existed for 2 months and then vanished, that data is more consistent with active processes than passive ones. And that should concern us. Or excite us. Or both. Avi mentioned in the interview that we do not have a resolved image of 3I Atlas. We cannot see its actual structure. All we have is light, reflected sunlight, and what we can infer from how that light changes over time. But even without an image, even without seeing the object directly, the light curve tells us something profound. 3I Atlas rotates every 16 hours. We know this. We can measure it. And as it rotates, if it were shaped like a typical comet, elongated, irregular, potato-shaped, we would see significant changes in brightness. More surface area pointing at us, brighter. Less surface area, dimmer. But that is not what we see. We see very little variability. The brightness stays nearly constant throughout the rotation. Which means, and this is critical, 3I Atlas is nearly spherical. Not perfectly spherical, there are slight variations, but close enough that the rotation barely affects the reflected light. Comets are not spheres. Asteroids are not spheres. Small bodies in space, they get battered by impact. They have irregular shapes. They tumble chaotically. The only objects in space that are naturally spherical are large enough for their own gravity to pull them into a sphere. And 3I Atlas is big, Manhattan-sized, but it is not that big. Not that big. It should not be spherical, but it is, unless it was manufactured that way. There, I said it. The thought that everyone is thinking but most scientists refuse to voice. What if 3i ATLAS was designed? What if that anti-tail was not a violation of physics, but rather evidence of a propulsion system we do not understand? What if the shift from anti-tail to normal tail in September was not a natural transition, but a change in operational mode? Avi did not say any of this directly in the interview. He's too careful for that. But he laid out all the pieces. He gave us the data. He showed us the anomalies. And then he said something that I think is the key to understanding his entire approach to this topic. He talked about Pascal's wager. Blaise Pascal, the 17th century mathematician and philosopher, he made an argument about God. He said, look, maybe God exists, maybe God does not exist. The probability might be small. But the implications of God existing are so enormous, infinite even, that we must take the possibility seriously. We must act as if it could be true, because the cost of being wrong, the cost of dismissing it, and then finding out it is real, that cost is infinite. Avi applies the same logic to 3IA TLAS. Maybe it is just a rock. Maybe it is just a weird comet with unusual composition and strange outgassing patterns. The probability of it being alien technology might be small, but the implications are so enormous that we must investigate seriously. We must gather every piece of data we can. We must not dismiss anomalies just because they make us uncomfortable. And this is where the interview gets really interesting, because Avi starts talking about intelligence agencies. He mentions October 7th, the Israeli intelligence failure. How they had a theory that Hamas would do nothing, how they received data suggesting otherwise, how they dismissed that data because it contradicted their theory, and how that dismissal led to catastrophic consequences. The parallel is obvious. The scientific community has a theory. Interstellar objects are rocks. They are comets. They are natural. Any data suggesting otherwise gets dismissed. Not because the data is bad, but because it contradicts the theory. And Avi is saying, look what happens when you do that with high-stakes scenarios. People die. Are we making the same mistake with 3IA TLAS? Today, October 29th, 3I Atlas is at perihelion, closest approach to the Sun. Whatever is going to happen, whatever data we are going to get, it is happening right now. The anti-tail mystery, the impossible physics of material flowing toward the Sun for 2 months, that is not resolved. That is not explained. And as we watch this object make its closest pass, as telescopes around the world point at this Manhattan-sized visitor from interstellar space, we have to ask ourselves a fundamental question. Are we watching a comet? Or are we watching something far more significant pretending to be a comet? The anti-tail does not care what we believe. It existed. Multiple observatories confirmed it. And then it stopped. Not gradually. Not with some smooth transition that would suggest natural processes. It just stopped. And that, more than anything else Avi said in that 3-hour interview, that is what keeps me awake at night. Because nature does not have an on-off switch. But technology does. The cosmic conspiracy. When scientists try to silence the truth. The moment Avi Loeb started questioning the water content of 3IA TLAS, the attacks began. Not subtle disagreements, not polite academic discourse, attacks. And what happened next reveals something darker about how science actually works when the stakes get high enough, when the implications become too uncomfortable, when the data threatens to overturn decades of carefully constructed narratives. Joe Rogan brought this up early in the interview, and Avi's response was telling. He mentioned, almost casually, that some people accused him of inventing 3I Atlas to distract from the Epstein files. Let that sink in for a moment. A Harvard professor, one of the most accomplished astrophysicists of our generation, was accused of somehow fabricating a Manhattan-sized object in space, visible to anyone with a telescope, to create a media distraction. The absurdity is breathtaking. But it tells you everything you need to know about the desperation of his critics. When you cannot attack the data, you attack the person. When you cannot refute the observations, you question the motives. This is not science. This is politics. And it has been happening to Avi Loeb for years now, ever since he dared to suggest it might be artificial. But the water controversy, that is where things get really interesting. Because this is not about speculation. This is about hard data. Multiple teams rushed to publish papers claiming they had detected significant amounts of water in 3IA-TLAS. Press releases went out. Headlines proclaimed that the mystery comet was just a normal icy visitor after all. Case closed. Everyone can go home. Except Avi looked at their papers. He actually read the data. And he said, no, this is not right. One team had error bars so large that their detection was essentially meaningless. Imagine someone telling you they measured the height of a building, and their measurement is 100 feet plus or minus 200 feet. That does not tell you anything. That is noise masquerading as data. But they published it anyway. They got their press release. They got their moment of fame. And when Avi pointed out that the data quality was insufficient, he was attacked for being overly critical, for being a contrarian, for demanding impossible standards. Another team took a different approach. They made assumptions. They assumed a certain amount of dust was blocking ultraviolet light. Based on that assumption, they calculated backward to infer water content. And they got a number, a big number, lots of water, enough water to say, see, it is just a comet, nothing unusual here. But here is the problem with assumptions. If your assumption is wrong, everything that follows is wrong. And Avi said, I do not think your assumption is correct. Show me the dust. Where is the evidence for all this dust that you are assuming exists? The scientific community did not appreciate that question. Avi mentioned in the interview that he was attacked for his skepticism, not by the public, not by conspiracy theorists, by other scientists, his peers, people who should know better, people who claim to value skepticism and rigorous analysis. They attacked him for doing exactly what scientists are supposed to do: question assumptions, demand evidence, refuse to accept conclusions that do not match the data. And then the Webb telescope looked at 3I-ATLAS. The James Webb Space Telescope, the most advanced infrared observatory ever built, turned its instruments toward this mysterious visitor and measured its composition directly. No assumptions, no error bars larger than the measurement itself, direct spectroscopic analysis. And what did Webb find? 4% water by mass. 4%. Not the massive water content the other teams claimed. Not enough to explain the observed activity through simple ice sublimation. 4%. Avi was right. The teams that rushed to publish were wrong. The press releases were wrong. The headlines were wrong. And more importantly, the narrative they were trying to construct, the comfortable story that 3I Atlas is just a normal comet, that narrative collapsed. But here is what makes this truly disturbing. When Webb released those results, when Avi was vindicated, did those teams issue corrections? Did they acknowledge their error? Did the journals that published their papers run retractions? Number. Silence. The scientific community just moved on, pretending the whole embarrassing episode never happened. And Avi, the person who was attacked for being right, he is still treated as the outsider, the troublemaker, the one who asks uncomfortable questions. This is not how science is supposed to work. Science is supposed to be self-correcting. When new data contradicts old conclusions, you update your conclusions. You admit error. You learn. But when the error threatens a deeply held belief, when admitting you are wrong means opening the door to possibilities you find frightening, suddenly the rules change. Suddenly it is more important to maintain consensus than to follow the data. The 4% water finding is devastating to the normal comet hypothesis. Because if 3I Atlas is only 4% water, what is the other 96%? Rock, metal, something else entirely? And more importantly, if it is mostly non-water material, how is it producing any outgassing at all? Water ice is what drives comet activity. That is comets 101. Heat up ice, it turns to gas, gas expands, creates pressure, pushes out dust, creates the coma and tail. That is the mechanism. But if you only have 4% water, you cannot produce the level of activity we're seeing. The math does not work, unless something else is driving the outgassing, unless there is another mechanism we do not understand, unless the activity is not passive sublimation, but active expulsion. Avi did not spell this out explicitly in the interview, but the implication hangs there like smoke. And I think that is why the scientific community reacts to skepticism about the water claims. Because if those claims were true, if 3i Atlas was full of water ice, then everything could be explained normally. It would be weird, sure, but ultimately comprehensible within our existing framework. But if the water content is low, if Webb is right and those rushed papers were wrong, then we are in uncharted territory. Then we have to consider explanations that make people very uncomfortable. Joe pushed Avi on this during the interview. He asked, could this still be natural? Could there be some explanation we are missing? And Avi's response was perfect. He said yes, it could be natural. We need to figure out why it is so unusual. Not we need to prove it is alien. Not we need to defend our theory. We need to figure out why it is unusual. That is the scientific approach. Start with the anomalies. Investigate them honestly. Follow where the data leads. But that is not what happened with the water controversy. What happened was the opposite. Start with the conclusion you want. Comet equals normal. Then work backward to find data that supports that conclusion. Ignore data that contradicts it. Attack anyone who questions your methods. Maintain the narrative at all costs. There is another layer to this conspiracy though, and Avi hinted at it when he talked about how visible 3i ATLAS is. He said you can buy a half-meter telescope online and see it yourself, from anywhere on Earth. It is not hidden, it is not secret. Anyone with basic equipment can observe this object and verify the data, which makes the accusation that he invented it particularly absurd. But it also makes the scientific community's reluctance to investigate properly even more troubling. Because if this was some faint, distant object that only a few observatories could see, you could understand some hesitation. Maybe the data is unclear. Maybe we need better instruments. But 3i Atlas is bright. It is accessible. We can study it in detail. We can answer these questions definitively. The only thing stopping us is willpower, or rather the lack of it, the fear of what we might find. Avi mentioned that no federal funding has been allocated for searching for technological signatures in space. $0. Meanwhile, over $10 billion is being spent on searching for microbial biosignatures on exoplanets. Think about that ratio, 10 billion to 0, for searching for microbes versus searching for technology. Even though tech would be far easier to detect, even though the implications of finding technology would be far more profound. Even though we know for certain that technological civilizations exist, we are one, while microbial life might not exist anywhere else. This is not a scientific decision. This is an ideological decision. The scientific establishment has decided, consciously or unconsciously, that searching for alien technology is not respectable. It is for cranks and conspiracy theorists. Real scientists search for microbes. Real scientists study exoplanet atmospheres looking for oxygen and methane. Real scientists do not waste time on little green men fantasies. Except Avi Loeb is a real scientist, one of the most cited astrophysicists alive, former chair of Harvard's astronomy department. Not exactly a fringe figure. And he is saying, look at this object. Look at the data. Something strange is happening. And instead of investigating, instead of allocating resources to get better observations, the response has been to marginalize him, to attack his credibility, to accuse him of seeking attention or inventing conspiracies. The water controversy crystallizes all of this perfectly. Bad data published and promoted because it supports the preferred narrative. Good skepticism attacked because it threatens that narrative. Vindication ignored because acknowledging it would mean admitting error. And through it all, the object itself continues its journey, indifferent to our academic politics and professional jealousies. Joe Rogan asked Avi how many comets we have observed, trying to establish a baseline for comparison. Avi said hundreds. Hundreds of comets, all behaving according to predictable patterns, all fitting our models, all explainable through standard physics and chemistry. But 3i Atlas does not fit. It breaks multiple patterns simultaneously. Low water content, anti-tail behavior, near spherical shape, nickel emissions. Each anomaly individually might be dismissible. Coincidences happen. Nature is complex. But when you stack them together, when you see multiple impossible things in the same object, at some point you have to stop calling them coincidences and start asking what they mean. The scientific method is supposed to be our tool for finding truth. You observe, you hypothesize, you test. You revise based on new. It is iterative, it is humble, It assumes we do not know everything and might be wrong about anything. But somewhere along the way, for topics that touch on existential questions, on humanity's place in the cosmos, the method got corrupted. Observation still happens, but hypothesis formation became constrained. Only certain hypotheses are acceptable. Only certain conclusions are allowed. Test whatever you want as long as your test confirms what we already believe. And anyone who steps outside those constraints, anyone who follows the data into forbidden territory, they get labelled contrarian, attention seeker, pseudoscientist. The labels are designed to isolate, to marginalize, to send a message to other scientists. Stay in line. Do not ask uncomfortable questions. Do not threaten the consensus. Your career depends on it. Avi Loeb has tenure at Harvard. He has already won the awards, published the papers, trained the students. His career is secure, which means he can afford to ask the uncomfortable questions. He can afford to follow the data wherever it leads. But most scientists are not in that position. Most scientists need grants. They need publications in prestigious journals. They need the approval of their peers, and so they self-censor. They see anomalies but do not mention them. They notice inconsistencies but do not pursue them. They play it safe. The water controversy is not really about water. It is about control. It is about who gets to decide what questions are worth asking and what answers are acceptable. And right now, the scientific establishment has decided that 3I Atlas must be a comet, must be natural, must not challenge our understanding in any fundamental way. The data can be massaged. The observations can be explained away. The anomalies can be ignored, as long as the conclusion remains comfortable. But comfort is not truth, and 4% water, confirmed by the most advanced telescope humanity has ever built, that is not comfortable. That is a problem that will not go away just because we refuse to look at it directly. The Manhattan-sized visitor, a monster in our cosmic backyard. When Avi Loeb said 3I Atlas is the size of Manhattan Island, he was not being poetic. He was being precise. And if you have ever stood in Manhattan, looked up at those towering buildings, walked those packed streets, felt the sheer density and scale of that island, then you understand what we are dealing with. This is not some small rock tumbling through space. This is not a boulder. This is an object so massive, so substantial, that comparing it to one of the most famous islands on Earth is the only way to convey its true nature. Manhattan is 13.4 miles long and 2.3 miles wide at its widest point. That is roughly 22 square miles of surface area, packed with skyscrapers, millions of people, infrastructure, history, culture. Now imagine that entire island, ripped from Earth, thrown into space, and sent hurtling toward our sun from the depths of interstellar space. That is what we are watching. That is what made its closest approach today. The scale matters for several reasons. First, it makes 3I Atlas impossible to fake. This was Avi's response to the absurd accusation that he somehow invented this object. He said, "If I could put a Manhattan-sized object in space, visible to anyone with a telescope, I would be more powerful than the Pope. It is a perfect rejoinder." Because the Pope at least claims divine authority. What kind of authority would you need to conjure a mountain into existence 4.5 astronomical units from Earth? But more than just refuting conspiracy theories, the size tells us something crucial about what this object can and cannot be. Small objects in space are common. Boulder-sized asteroids, house-sized comets, these zip past Earth regularly. We barely notice them. But Manhattan-sized objects, those are rare. Those are significant. Those contain enormous amounts of mass, enormous amounts of material, enormous amounts of potential energy. And when an object that large displays anomalous behavior, when it does things that smaller objects do not do, you cannot just wave it away as measurement error or optical illusion. Avi emphasized during the interview that anyone on Earth can observe 3I Atlas with commercially available equipment. A half-meter telescope, something amateur astronomers own, something you can order online that is sufficient. You do not need Hubble. You do not need Webb. You do not need some classified military observatory. Just you, a decent telescope, and a clear night sky. The object is bright enough, substantial enough, close enough that citizen science can verify everything the professionals are saying. This democratization of observation is crucial because it means the data cannot be hidden. It cannot be classified. It cannot be controlled by some shadowy government agency or suppressed by a cabal of skeptical scientists. 3i Atlas is out there for everyone to see. The observations are reproducible. The anomalies are real. This is not blurry footage of lights in the sky. This is solid, verifiable, repeated observation of something genuinely strange. The brightness of the object correlates directly with its size. When you see 3i Atlas through a telescope, you are seeing sunlight reflected off an enormous surface. The amount of light tells us about the surface area. The way that light changes over time tells us about rotation and shape, and what we're seeing is an object that reflects light consistently, without the dramatic variations you would expect from something irregularly shaped. Think about the moon for comparison. The moon is spherical, and as it orbits Earth, we see different phases, but the overall brightness stays relatively constant regardless of which side faces us. That is what spheres do. They present consistent surface area in all directions. Now think about something shaped like a potato or a cigar. As it tumbles through space, sometimes you see the long side, lots of surface area, bright reflection. Sometimes you see the end, small surface area, dim reflection. The brightness varies dramatically. 3i Atlas barely varies. 16-hour rotation period, confirmed. But minimal brightness changes, which means it is nearly spherical, and that's weird for something this size. Objects in space get hit by other objects. They fracture. They break apart. They tumble chaotically. They are not neat. They are not symmetric. Unless gravity is strong enough to pull them into a sphere, and for rocky or icy objects that requires being pretty massive. Larger than 3i Atlas should be, so we have a contradiction. The object is big enough to be easily visible, to show clear structure in its light signature, to be observed by amateurs and professionals alike. But it is too small to naturally form a sphere through gravitational rounding, yet it is nearly spherical. How? Joe asked Avi directly about imaging. Do we have actual pictures of the object itself? Can we see what it looks like? And Avi said no, we do not have a resolved image. What we have is reflected light, spectroscopic data, brightness over time. We are doing astronomy the old-fashioned way, inferring structure from light curves. But he mentioned something interesting. He said if there had been Mars orbital footage, depending on how large the object is, we might have gotten better imagery. Wait, Mars orbital footage? Why would Mars be relevant? Because 3i Atlas's trajectory brought it relatively close to Mars's orbital path. Not close enough to impact, but close enough that if we had been watching at the right time with the right instruments, we might have captured something. But we were not watching. Or if we were, nobody has released those images. Which is strange, because Mars orbiters are constantly taking pictures. NASA has multiple spacecraft around Mars. The Europeans have orbiters. If 3i Atlas passed anywhere near Mars's orbit during an observable window, someone should have images. The absence of those images raises questions. Are they classified? Did we simply miss the opportunity? Is the object smaller than we think and would not have shown up clearly? Or, and this is pure speculation, did someone decide that releasing high-resolution imagery of 3i Atlas would raise more questions than it answers? Size also matters when we talk about composition. A Manhattan-sized object contains immense amounts of material. Avi mentioned that spectroscopic analysis shows 4% water by mass. 4% of Manhattan is still a lot of water, millions of tons, but it is also 96% something else. Rock, presumably. Metal, possibly. Other compounds, certainly. The question is what compounds, and in what ratios. And here is where the nickel comes in. Avi mentioned during the interview that 3i Atlas sheds nickel. Not iron. Not the usual mix of silicates and carbonaceous compounds you see in comets. Nickel. Specifically nickel. That is bizarre. Nickel does occur in space, of course. Metallic asteroids can have nickel-iron compositions. But comets, objects coming from the outer reaches of solar systems where ice dominates, they do not typically shed pure nickel. So either 3i Atlas, formed in an environment very different from our Kuiper Belt and Oort cloud, some interstellar region where nickel-rich compounds are common, or its composition is not natural. Because nickel has some interesting properties. It is dense, it is durable, it is resistant to corrosion, it is useful for, say, spacecraft construction, heat shields, structural components, reflective surfaces. I'm not saying 3i Atlas is a spacecraft. I am saying that if you were designing a large interstellar probe and you wanted it to withstand the harsh environment of space for potentially millions of years, nickel would be a reasonable material to include. And if that probe was shedding particles, either through degradation or active outgassing, you would detect nickel in the spectrum. The size of 3i Atlas also affects how we think about its trajectory and behaviour. Small objects can be pushed around relatively easily. Radiation pressure, solar wind, gravitational perturbations from planets, these can significantly alter the orbit of something small. But Manhattan-sized objects have serious momentum. Changing their trajectory requires substantial force. So when 3i Atlas showed that anti-tail behaviour when material was flowing toward the Sun during July and August, we are not talking about a few dust particles getting blown the wrong way. We are talking about measurable, sustained, directional outgassing from an enormous object. That requires energy, lots of energy. Where is that energy coming from? With normal comets, it is solar heating. Ice absorbs sunlight, warms up, sublimates into gas, and the expanding gas carries dust particles along. Simple thermal process. But 3i Atlas was displaying the anti-tail behaviour when it was still relatively far from the Sun. The temperatures at 4+ astronomical units are cold, way too cold for significant water ice sublimation, especially from an object that is only 4% water by mass. So what was driving the activity? What was providing the energy to expel material strongly enough and directionally enough to create an observable anti-tail? And why did it stop in September? Did the object cool down? Unlikely, since it was getting closer to the Sun, not farther away. Did it run out of volatile material? Possible, but then why did a normal tail appear afterward? If you exhausted your volatiles, you should go dormant, not switch to a different type of activity, unless the activity is controlled. Unless something on or in that Manhattan-sized object decided to change operational modes. Stop doing this thing, start doing that thing, switch from anti-tail to normal tail. Not because of changing external conditions, but because of internal decision-making processes. I keep coming back to that word, decision. Because everything about 3i Atlas's behaviour suggests decision-making. The timing, the transitions, the anomalies that appear and disappear. Natural processes are gradual. They respond to external forces predictably. You heat up a comet, it outgasses. You cool it down, it stops. Simple cause and effect. But 3i Atlas does not follow that pattern. It does something impossible, then stops, then does something normal but insufficient, like it is testing, or signalling, or malfunctioning. Avi did not use any of this language in the interview. He is too careful. But when Joe pushed him with that animal in the backyard analogy, when he described seeing a creature with a tail coming from its forehead and mass 1,000 times greater than a cat, the point was clear. Once you accumulate enough anomalies, once the object is large enough and strange enough, and consistently wrong enough, you have to consider that your initial classification is incorrect. It is not a cat. It might look vaguely cat-like from a distance. It might be in your backyard where cats usually appear. But it is not a cat, and 3i Atlas is not a comet. It might look vaguely comet-like. It might be in the inner solar system where comets usually appear, but it is not a comet. So what is it? That is the question Avi is asking. That is the question the scientific community refuses to seriously investigate. Because asking that question, really asking it, means considering answers that make everyone uncomfortable. Means allocating resources to observations that might reveal something paradigm-shifting. Means risking your reputation on data that could turn out to be mundane after all. But here is the thing about risk. When you are dealing with a Manhattan-sized object from interstellar space, displaying multiple simultaneous anomalies during the most significant close approach we will see in our lifetimes, the risk of not investigating thoroughly is far greater than the risk of looking foolish. Because if there is even a small chance that 3i Atlas is something other than a rock, if there is even a possibility that we are watching the first confirmed close approach of alien technology, then every telescope on Earth should be pointed at it right now. Every instrument we have should be gathering data. Every scientist who can contribute should be analysing. Instead, we get press releases about water content from teams with bad data. We get silence from the scientific establishment. We get conspiracy theories about Epstein file distractions. and we get one Harvard professor, stubborn and brilliant and unwilling to look away, saying over and over, "This is unusual, we need to investigate, let us follow the data." The size of 3i Atlas means we cannot plead ignorance. We cannot say it was too faint to see or too far away to study. It is here. It is huge. It is observable. And today, October 29th, at perihelion, it is as close as it will ever be. Whatever data we can gather, we need to gather now. Whatever observations are possible, we need to make them now. Because this Manhattan-sized mystery will not wait for us to overcome our fears and prejudices. It will continue on its trajectory, back out into the darkness, and we'll be left with incomplete data and unanswered questions. Unless we choose differently, unless we decide that finding truth matters more than maintaining comfortable fictions, unless we acknowledge that sometimes, just sometimes, the impossible thing in your backyard is not a cat at all, shedding nickel and secrets, the chemical fingerprint of the unknown. There is a moment in the Joe Rogan interview where Avi Loeb mentions, almost in passing, that 3i Atlas sheds nickel. And if you are not paying close attention, if you do not understand the implications, you might miss it entirely. Joe moved right past it. The conversation continued. But that single observation, that chemical fingerprint, might be the most damning piece of evidence we have that something fundamentally strange is happening with this object. Nickel, not iron, not the standard mix of rocky silicates, not the organic compounds you find in primitive carbonaceous asteroids, not the water ice and carbon dioxide you expect from comets. Nickel, elemental nickel, showing up in spectroscopic analysis as material gets expelled from the object. Let me explain why this matters. When we analyse light from comets, we are looking at emission lines, specific wavelengths where atoms and molecules absorb or emit photons. Each element has a unique signature, like a fingerprint. When sunlight hits a comet and heats it up, various compounds sublimate and fluoresce, and we can identify them by their spectral lines. Water shows up clearly. So does carbon monoxide, carbon dioxide, cyanogen, various organic compounds. We have decades of data on what comets are made of and what they release as they approach the sun, not on that standard list. Oh, trace amounts appear sometimes. Metals exist in space, they get incorporated into solar system formation. You can find tiny quantities of lots of elements if you look hard enough. But shedding nickel, releasing it in detectable quantities as a primary emission product, that is not comet behaviour. That is asteroid behaviour. Specifically, metallic asteroid behaviour. The kind of object that formed in the hot inner regions of a solar system, where temperatures were high enough for metals to condense, while volatiles like water were driven away. So immediately we have a contradiction. 3i Atlas behaves like a comet in some ways. It has a coma, material surrounding it. It showed outgassing activity. It developed tails, normal and anti. These are comet characteristics. But its composition suggests a metallic asteroid. And those two categories do not overlap. Comets form far from stars, in cold regions where ice dominates. Metallic asteroids form close to stars, in hot regions where rock and metal dominate. You do not get objects that are both. Unless the object did not form naturally, unless it was constructed. Because if you are building something designed to travel between stars, you absolutely would use metals. You would use durable, heat-resistant structural materials. And nickel fits that profile perfectly. Nickel has some remarkable properties that make it ideal for space applications. It is dense, but not as heavy as some other metals. It resists corrosion better than iron. It maintains strength across wide temperature ranges. It can be alloyed with other metals to create materials with specific properties. And crucially, it reflects certain wavelengths of light very effectively, which matters if you are worried about radiation exposure during a long interstellar journey. Modern spacecraft use nickel alloys extensively. The International Space Station has nickel components. Satellites use nickel-cadmium batteries. Heat shields incorporate nickel for its thermal properties. If humanity can recognize the utility of nickel for space technology with our primitive capabilities, imagine what a truly advanced civilization could do with it. But let me be clear. The presence of nickel alone does not prove 3i Atlas is artificial. What makes it significant is the context. The nickel emission combined with the anti-tail, combined with the low water content, combined with the near-spherical shape, combined with the behavioural changes. No single anomaly is conclusive, but when you stack them together, When you see multiple impossible things in the same object, the probability that all of them are natural coincidences drops towards zero. There's another aspect to the nickel emission that Avi did not elaborate on during the interview, but it is worth considering. How is the nickel being released? With water ice, the mechanism is straightforward. Solar heating causes sublimation. Ice turns directly to gas. Gas expands and carries dust particles. But nickel does not sublimate at the temperatures we're talking about. The boiling point of nickel is 2,913 degrees Celsius. Even at perihelion, even at the closest approach to the sun, 3I Atlas is nowhere near hot enough to vaporize nickel. So the nickel must be in particulate form, tiny grains, being expelled by some other process. But what process? If it is embedded in ice, and the ice sublimates, you would expect a mix of materials, not predominantly nickel. If it is being ablated from the surface by solar wind or micrometeorite impacts, you would expect a gradual, continuous release, not the variable emission we're seeing. If it is being actively expelled, pushed out by internal pressure or mechanical processes, then we are back to considering artificial systems. There is a hypothesis, not mentioned in the interview but worth exploring, that 3I Atlas could be a fragment of a larger metallic body that broke apart. Maybe it is a piece of a destroyed planet, ejected during some catastrophic collision in another solar system millions of years ago. That would explain the metallic composition. But it does not explain the activity. Dead fragments do not outgas. They do not develop antitails. They do not change behavior modes. They just tumble silently through space, inert and cold. The spectroscopic data from 3I ATLAAS shows other interesting features beyond nickel. There are emission lines consistent with cyanide production. Cyanide, for context, is not unusual in comets. Many comets produce cyanogen and related compounds as they heat up, but the ratio of cyanide to water in 3I Atlas is off. Given the low water content Webb confirmed, the amount of cyanide being produced is higher than expected, much higher. Cyanide production in comets comes from the breakdown of more complex organic molecules. You need carbon and nitrogen in the right configurations, and you need enough energy to drive the chemical reactions. But if you only have 4% water by mass, where are these complex organics coming from? Where is the carbon source? And why is it producing cyanide specifically, rather than other possible breakdown products? I am not suggesting 3I Atlas is deliberately producing cyanide as some kind of weapon or defense mechanism, but I am saying the chemistry does not make sense for a natural object with the composition we have measured. The pieces do not fit together. It's like finding a car engine that runs on water, produces gasoline as exhaust, and has a transmission made of glass. Each individual component might exist in nature, but the combination is nonsensical. Avi brought up during the interview his experience with other scientific controversies. He mentioned teams that claimed to detect water, teams whose measurements were wrong, and how he was attacked for pointing out the flaws in their data. The same pattern applies to composition analysis. When spectroscopic data shows something unexpected, something that does not fit the narrative, there is enormous pressure to reinterpret it, to explain it away, to find some alternative reading that makes it normal. And maybe that is happening with the nickel. Maybe someone looked at those spectral lines and thought, well, it could be nickel, or it could be this other compound that we would rather it be, so let us call it that instead. Maybe the data has been massaged to be less alarming. Maybe the public reports we are seeing are sanitized versions of what the raw data actually shows. I do not have proof of this. But given how the water controversy played out, given the institutional resistance to acknowledging anomalies, it would not surprise me. There is one more piece to the nickel puzzle that deserves attention. Metallic objects in space have different thermal properties than icy ones. Metal conducts heat efficiently. It absorbs radiation and distributes that energy across its structure. Ice, by contrast, is an insulator. It absorbs heat locally, sublimates, and the resulting gas carries heat away. These different thermal behaviors affect how an object responds to sunlight, how its temperature changes with distance from the sun, and crucially, how it radiates infrared light. We have infrared observations of 3I ATLAS. Multiple telescopes have measured its thermal emission, and the data from what has been publicly released shows thermal behaviour more consistent with a solid object than a fluffy ice ball. The temperature distribution is more uniform than you would expect for a comet. The way it cools as it rotates suggests efficient heat distribution, which implies good thermal conductivity, which implies significant metal content. Again, no single measurement proves anything. But the infrared data supporting metal content, combined with the spectroscopic detection of nickel emission, combined with everything else, it all points in the same direction. This object has substantial metallic components, and metallic comets do not exist in nature. Joe asked Avi at one point about how we determine composition, how we know what things are made of when we cannot touch them. And Avi explained spectroscopy, how light carries information, how we can read the chemical signatures. But what he did not say, what the interview did not really get into, is how much interpretation goes into that reading. Spectral lines can overlap, signals can be ambiguous, background noise can contaminate measurements, and when you are dealing with a unique object, when you do not have comparison cases, when you are seeing emissions you have never seen before, the interpretation becomes subjective. Whose interpretation do we trust? The teams that rush to publish water detections with questionable data? The establishment scientists who insist everything must have a conventional explanation? Or the lone voice saying, look, this is really strange, we need to investigate more carefully. The nickel emission is not going away. It is in the data. Multiple independent observations have confirmed it. This is not measurement error. This is not instrumental artifact. 3I Atlas is releasing nickel into space as it travels through our solar system. And until someone can provide a plausible natural mechanism for how an object from interstellar space, displaying comet-like activity, can be predominantly metallic and actively shedding elemental nickel, we have to consider the possibility that the object is not natural at all. Consider what happens to a spacecraft after millions of years in space. Micrometeorite impacts, cosmic ray bombardment, thermal cycling, slow degradation of materials. If 3I Atlas is ancient technology, if it has been travelling for eons, it would be shedding particles. Protective coatings would erode, structural components would develop microfractures, and if those components are nickel-based, spectroscopy would detect nickel. Ionoscopy would detect nickel. I am not claiming this is definitely what is happening. I am saying it fits the data better than any natural explanation I have heard. And the fact that the scientific community is not seriously exploring this possibility, the fact that suggesting it gets you labelled a pseudoscientist or attention seeker, that tells you more about the sociology of science than it does about the nature of 3I Atlas. The chemical fingerprint is there, written in light, confirmed by multiple instruments, reproducible and verifiable. Nickel, not in trace amounts, not as a minor spectral feature, as a significant emission product. And that fingerprint is telling us something. Whether we choose to listen, whether we have the courage to follow the implications, that is up to us. But the data does not care about our comfort. The nickel does not care about our theories. It is there, in the spectrum, waiting for someone brave enough to read what it is actually saying. The sphere that shouldn't exist, shape, spin, and impossibilities 16 hours. That is how long it takes 3I Atlas to complete one full rotation. We know this with certainty because we can measure it. As the object spins, the amount of sunlight it reflects changes slightly, creating a periodic brightness variation. 16 hours, over and over, consistent and measurable. But here is what should be happening and is not. That brightness should be changing dramatically. It should be swinging from bright to dim and back again as different surface areas point toward Earth. But it barely changes at all. Avi explained this to Joe using straightforward physics. If you have an elongated object, a cigar shape or a potato shape, and it tumbles through space, sometimes you see the long side with lots of surface area reflecting light, and sometimes you see the narrow end with minimal surface area. The difference in brightness between those two orientations can be factors of 2, 3, even 10 for highly elongated objects. We see this with asteroids all the time. The light curve tells us the shape. 3I Atlas has almost no variation, maybe 10 or 15% brightness change over its 16-hour rotation. That is the signature of something nearly spherical. Not perfectly round, there are slight irregularities, but close enough that rotation barely affects the reflected light. And this is deeply, fundamentally wrong for an object of this size and origin. Small objects in space are irregular. They have to be. They form from collisions, accretion of smaller pieces, gravitational capture of debris. The process is violent and chaotic. You end up with lumpy, asymmetric shapes. Look at any asteroid we have visited up close. Eros, Itokawa, Bennu, Ryugu, they are all potatoes. Weird shapes with craters and boulders and flat spots and ridges. Nothing smooth, nothing symmetric. Larger objects can be spherical, but only if they are large enough for their own gravity to overcome the mechanical strength of rock. This threshold is called the hydrostatic equilibrium limit. For rocky bodies, it is somewhere around 500 to 1,000 kilometers in diameter depending on composition. Below that size, the object simply is not massive enough for gravity to crush it into a sphere. Above that size, gravity wins, pulls everything toward the center, and you get a round body. That is why planets are spheres and asteroids are potatoes. 3i Atlas is somewhere between a few kilometers and maybe 20 kilometers across based on brightness and distance estimates. That is nowhere near large enough to achieve hydrostatic equilibrium if it is made of rock or ice. It should be potato-shaped. It should show massive brightness variations as it rotates. But it does not. So either our size estimate is wrong, and it is actually much larger than we think, which would require it to be much darker than any known solar system object, or it is not held together by gravity alone. Something else is maintaining its shape, something structural, something engineered. During the interview, Joe asked if we could determine the shape from imaging, and Avi said, no, we do not have resolved images, we are inferring shape from the light curve. But he also mentioned that the rotation period is confirmed at 16 hours, which means we have been watching this object spin for months now, collecting data through multiple observation windows, and the story stays the same. Minimal variation. Near spherical shape. There is a concept in spacecraft design called structural integrity. If you are building something meant to survive interstellar space, meant to withstand thermal stress and impacts, and millions of years of exposure to radiation, you do not just throw materials together and hope for the best. You design a structure. You create a framework that distributes stress, maintains shape, protects internal components. And the most efficient structure for distributing stress in all directions is a sphere. Geodesic domes, ball bearings, pressure vessels, spherical fuel tanks. Architects and engineers on Earth figured this out long ago. Spheres are strong. They have the minimum surface area for a given volume, which minimizes material usage. They have no stress concentrations at corners or edges. They respond to external pressure uniformly. If you were designing a probe to cross interstellar space, a sphere or near-sphere would be a logical choice. But natural objects do not follow engineering principles. Natural objects follow the messy, chaotic rules of collisions and gravitational interactions and random accumulation. They are not optimized. They are not efficient. They are whatever shape results from their formation process and subsequent evolution. And that shape is never a neat, symmetric sphere unless gravity forces it to be. 3i Atlas is presenting us with an impossibility. It is too small to be spherical naturally, yet it is spherical. It is tumbling through space with a measured rotation period, yet its brightness barely changes. The data is clear, the observations are repeatable, and the conclusion is unavoidable. This object maintains its shape through something other than natural processes. There's another aspect to the rotation that deserves scrutiny. 16 hours is a relatively slow rotation for an object this size arriving from interstellar space. Small bodies tend to spin faster because they have been tumbling for millions or billions of years, accumulating angular momentum from countless tiny impacts. But 16 hours suggests either the object is more massive than we think, which brings us back to the size problem, or something has been controlling its spin rate. A deliberately designed rotation rate makes sense if you're trying to simulate gravity for biological occupants. 16 hours is not quite fast enough for comfortable artificial gravity through centripetal force, but it is in the ballpark, or maybe the rotation serves some other purpose. Thermal management, perhaps. Keeping one side from getting too hot while the other freezes. Distributing power generation if you have solar collectors on the surface. Maintaining attitude control and stability during a long journey. I'm speculating now, extrapolating beyond what the data strictly shows. But the data itself, the 16-hour rotation with minimal brightness variation, that is not speculation. That is measurement. And and it does not fit any natural formation scenario we understand. Avi made an interesting comparison during the interview. He talked about Arthur C. Clarke's Rendezvous with Rama, a science fiction novel about a cylindrical alien spacecraft that enters the solar system. The spacecraft in that story is tens of kilometers long, it rotates to create artificial gravity, and it passes through the solar system without stopping, without communicating, just a brief visit before continuing into the darkness. The parallels to 3I-AETLAS are obvious. Large object from interstellar space, unusual shape, controlled rotation, brief passage through our neighbourhood. Clarke wrote that book in 1973, over 50 years ago, and somehow he imagined almost exactly what we are now observing. Was he prophetic, lucky, or was he extrapolating from basic principles, recognizing that if alien technology ever visited us, it would look strange but not random, designed but not familiar? Following engineering logic we could understand even if we could not replicate it. The difference between Clarke's cylinder and 3I Atlas's sphere might not be significant. Both shapes offer structural advantages. Both would appear anomalous compared to natural objects, and both would rotate because rotation solves multiple problems for long-duration spaceflight. Stability, thermal management, possibly artificial gravity. The specific geometry matters less than the fact that geometry exists at all, that the object has a defined, maintained shape rather than the random lumpiness of asteroids. Joe pushed Avi on whether this could still be natural, whether we are missing some obvious explanation. And Avi kept coming back to the same point. We need to figure out why it is so unusual, not assume it is natural and work backward. Not dismiss the anomalies because they are uncomfortable, actually investigate, actually try to understand what we are seeing. But investigating the shape rigorously requires better data than we currently have. We need resolved imaging. We need to actually see the object, not just infer its properties from brightness variations. And that requires either getting lucky with Mars orbital assets, which may or may not have captured anything useful, or waiting for the next interstellar visitor, and being prepared with the right instruments in the right places at the right time. Today, at perihelion, 3I Atlas is at its brightest and closest. If we are ever going to get decent imagery, it would be now. But as far as I know, no special observing campaigns were organised. No space agencies repositioned assets to maximise data collection. The object is just passing through, unmonitored beyond routine observations, and we are relying on whatever amateur astronomers and university telescopes happen to point in the right direction. This is negligence, pure and simple. We have a potentially paradigm-shifting object making its closest approach, displaying multiple anomalies, including impossible shape characteristics, and the response from the scientific establishment is a collective shrug. Some papers will get written, some data will get analysed eventually, but no coordinated effort, no Manhattan Project for interstellar object investigation, no recognition that we might be looking at the most important astronomical observation in human history. The near-spherical shape of 3I-ATLAS is not subtle. It is not a borderline case where you could argue for natural processes with enough assumptions. It is blatant. The light curve is wrong, the rotation period is measured, the brightness variation is minimal. These are facts, not interpretations, and facts that contradict our understanding of how natural objects behave should trigger intense curiosity, not defensive rationalization. There is a principle in science called Occam's razor. When you have multiple explanations for something, choose the simplest one. But simplest does not mean most comfortable. It means the explanation that requires the fewest additional assumptions. The natural comet explanation for 3I-ATLAS requires assuming multiple extremely unlikely coincidences, unusual composition, weird thermal behavior, anomalous outgassing, perfect shape despite insufficient mass. Each assumption individually is possible but improbable. Together they become absurd. The artificial object explanation requires only one assumption. That technological civilizations exist elsewhere, and sometimes they send probes to other star systems. We know technological civilizations exist because we are one. We know interstellar probes are possible because we have designed them, Voyager being the obvious example. So the artificial explanation requires assuming something we know to be possible happened in a place other than Earth. That is simpler. That is fewer assumptions. That is Occam's razor properly applied. But people do not want simple. They want safe. They want explanations that do not challenge their worldview. They want to believe we are alone, or at least that if we are not alone, aliens have the courtesy to stay far away and not show up in our telescopes doing impossible things. The sphere that should not exist threatens that comfort. It forces us to confront possibilities we would rather ignore. 16 hours of rotation, minimal brightness variation, near perfect spherical shape. These are the facts, written in light, measured by instruments, confirmed by multiple observers, and these facts are telling us that 3i Atlas is not what we want it to be. It is not a reassuring chunk of ice and rock following predictable laws. It is something else, something that maintains its shape through design rather than gravity. Something that rotates with purpose rather than chaotic tumbling. The sphere exists whether we acknowledge it or not. The question is whether we have the courage to admit what that sphere implies. Pascal's wager meets black swan events, the intelligence agency approach. Blaise Pascal was not thinking about alien spacecraft when he formulated his famous wager in the 17th century. He was thinking about God, about faith, about how to make rational decisions in the face of uncertainty. But the logic he developed, the mathematical framework he created for weighing infinite consequences against finite probabilities, that logic applies perfectly to 3i Atlas, and Avi Loeb knows it. During the interview, Avi walked Joe through the reasoning with precision. He said, look, you might think the probability of God existing is small, but the implications if God does exist, those implications are infinite. Eternal salvation or damnation, infinite reward or infinite punishment. So even if the probability is tiny, even if you are 99% certain God does not exist, that 1% possibility multiplied by infinite consequences means you must take it seriously. You must act as if it could be true. Now replace God with alien technology. The probability might be small. Most scientists would say it is very small. They would argue that the vast majority of interstellar objects are natural, that anomalies can be explained through exotic but natural processes, that we should default to conventional explanations until absolutely forced to consider alternatives. Fine. Let us say the probability that 3i Atlas is artificial is only 1%, or even 1/10 of 1%. Does that mean we should ignore it? Number. Because the implications are not infinite, but they are civilization altering. If 3i Atlas is alien technology, everything changes. Our understanding of our place in the universe, our technological trajectory, our social structures, our economics, our politics, everything. Markets would crash and rebuild overnight. Governments would face legitimacy crises. Religious institutions would need to reframe their entire cosmology. Scientific paradigms would collapse and new ones would emerge. The human story would fundamentally change in ways we cannot even predict. That's what Avi means when he talks about Pascal's wager for alien technology. The stakes are so high that even extremely low probability scenarios demand serious investigation. This is not wild speculation. This is basic risk analysis. Intelligence agencies understand this instinctively. You do not ignore low probability, high impact threats just because they seem unlikely. You investigate, you prepare, you treat them with the seriousness their potential consequences demand. And then Avi brought up October 7th, the Israeli intelligence failure, the Hamas attack that caught everyone by surprise despite warning signs. He did not mention this casually. He is Israeli. He knows people affected by that catastrophe, and he understands exactly how intelligence failures happen. You have a theory. The theory says nothing will happen. Data comes in suggesting maybe something will happen. But the data contradicts the theory. And theories are comfortable. Theories give us certainty. So we dismiss the data. We explain it away. We find reasons to doubt it. And then the low probability event occurs and people die. The scientific establishment has a theory about interstellar objects. They are rocks. They are comets. They are natural. This theory is comfortable. It fits with our current understanding. It does not require rethinking fundamental assumptions. But data keeps coming in that contradicts the theory. Oumuamua accelerating without visible outgassing. 3i Atlas with its anti-tail, its nickel emissions, its spherical shape, its behavioral transitions. Anomaly after anomaly, each one explained away individually. The pattern never acknowledged collectively. This is exactly how intelligence failures happen. And Avi is saying, look, the consequences of being wrong here, of dismissing anomalies because they threaten our comfortable theory, those consequences are enormous. We cannot afford to make the October 7th mistake with 3i Atlas. We cannot let theoretical preferences override empirical observation. Because if we are wrong, if we dismiss this and it turns out to be the first confirmed detection of alien technology, we will have wasted the most important scientific opportunity in human history. Joe understood this immediately. He pushed back with the obvious question, could this still be natural? And Avi's answer was perfect. Yes, it could be. We need to figure out why it is so unusual, not assert that it must be natural and work backward. Not dismiss the possibility of artificial origin. Actually investigate. Treat this as the high-stakes scenario it is. Apply intelligence agency thinking to astronomical observation. There is a term in risk analysis called black swan events. Nassim Taleb popularized it, though the concept is older. A black swan is something that seems impossible until it happens. Before Europeans discovered Australia, all swans were white. Every swan ever observed, every swan in historical record white. The theory was solid. Swans are white. Then explorers found black swans in Australia, and the theory collapsed. The impossible turned out to be real. But here is the key insight about black swans. You can prepare for them even if you cannot predict them specifically. You can build systems robust enough to survive unexpected shocks. You can avoid overconfidence in your models. You can maintain flexibility and openness to anomalous data. And you can recognize that just because something has never happened before does not mean it cannot happen. We have never confirmed alien technology. Every anomalous signal, every strange observation, every UFO report has eventually resolved into something natural or human, made or simple misidentification. The historical record is clear. Aliens have not visited. Alien probes have not entered our solar system. This is the white swan argument. We have only ever seen white swans, therefore swans are white. Therefore, this thing in our solar system must be a white swan, even if it looks black. But Australia exists. Black swans exist. And the universe is much larger and older than Australia. Billion stars. Most formed billions of years before our sun. Billions of potentially habitable planets have existed far longer than Earth. Intelligence emerged here from chemistry. The same chemistry exists everywhere. The same physics applies everywhere. So the probability that we are the first and only technological civilization is vanishingly small, which means black swans are not just possible, they are inevitable. Somewhere, sometime, a human observer will point a telescope at something from interstellar space and realize they are looking at technology. The only question is whether that observer will be brave enough to say it out loud, and whether the scientific community will be wise enough to listen. Avi is trying to be that observer. He looked at Oumuamua and said, "This is strange enough to investigate seriously." He was attacked, ridiculed, marginalized, called a publicity seeker. Now 3i Atlas appears with even more anomalies, and he is saying the same thing. Investigate seriously. Consider all possibilities. Do not let theoretical preferences override observation. And the response from the establishment is the same. Dismissal, rationalization, attacks on his credibility. This is the October 7th pattern playing out in real time. Data contradicting the theory. Theory winning because it is comfortable. Warnings dismissed because they threaten consensus. And the low probability, high impact event creeping closer while everyone looks away. Intelligence agencies, when they function properly, have processes to avoid this trap. They do red team exercises where someone is assigned to argue the opposite of the consensus view. They maintain multiple hypotheses simultaneously. They do not allow any single theory to become so dominant that contradictory evidence gets automatically dismissed. They understand that being wrong about a black swan costs more than being overly cautious about white swans. Science needs the same discipline. We need institutional structures that reward anomaly hunting, that protect researchers who challenge consensus, that allocate resources to investigating low probability but high impact possibilities. Right now we have the opposite. We have structures that punish deviation from orthodoxy, that reward confirmations of existing theory, that make career advancement dependent on playing it safe. And this is not just bad for individual scientists, this is bad for humanity. Because we are living through a unique moment in history. For the first time, we have instruments sensitive enough to detect interstellar objects as they pass through our solar system. For the first time, we can observe them in detail, measure their properties, track their behaviour. We're opening a new window on the universe, and what we see through that window might change everything. But only if we look, only if we allocate resources, only if we take the observations seriously, only if we apply Pascal's wager and intelligence agency risk analysis to the question of whether we are alone. Avi mentioned during the interview that no federal funding has been allocated to searching for technological signatures. 0. While $10 billion goes to searching for microbial biosignatures. This is not a scientifically justified allocation. This is an ideological choice, an implicit assumption that intelligence is rare or absent, that technology is not worth looking for, that we can safely ignore the possibility of alien probes and focus on alien microbes instead. But finding microbes would be scientifically interesting and philosophically significant. Finding technology would be practically transformative. Microbes cannot teach us anything beyond their own biology. Technology could contain information. Technology could reveal physical principles we have not discovered. Technology could reshape our understanding of what is possible. The asymmetry is stark. Low investment, high potential return. This is exactly the kind of scenario Pascal's wager was designed for. Even if the probability is low, the magnitude of the potential outcome justifies serious resource allocation. But we are not doing it. We are making the same mistake intelligence agencies made before October 7th. We have a comfortable theory, and we are sticking to it regardless of what the data suggests. Today, as 3I Atlas reaches perihelion, we have a choice. We can continue dismissing anomalies, explaining away each strange observation individually, maintaining our comfortable belief that interstellar objects are just rocks. Or we can acknowledge that multiple simultaneous anomalies in a single object demand investigation. We can apply proper risk analysis. We can treat this as the potential black swan event it is. The implications of being wrong are not infinite like in Pascal's original wager, but they are large enough. Large enough that 1% probability times civilization changing consequences equals mandatory serious investigation. Large enough that dismissing this possibility is not scientific caution, but institutional cowardice. Large enough that history will judge us harshly if we let this opportunity slip away because we were too afraid to admit we might be seeing something unprecedented. Avi ended this part of the conversation by saying, intelligence agencies will not make the October 7th mistake again. They learned. They adapted. The question is whether the scientific community can learn the same lesson. Whether we can recognize that low probability does not mean no probability. Whether we can build institutions resilient enough to consider black swan possibilities without collapsing into conspiracy thinking or losing empirical rigor. The wager is on the table. The stakes are clear, and 3I Atlas is forcing our hand. We can fold, dismiss it as natural, move on with our comfortable theories intact, or we can call, investigate seriously, and potentially win the most significant pot in scientific history. Pascal would know which choice to make. Intelligence analysts would know. The question is whether scientists, supposedly trained to follow evidence wherever it leads, can muster the same courage. Rendezvous with Rama, when science fiction predicts reality. Arthur C. Clarke died in 2008. He never saw Oumuamua. He never saw 3I Atlas. But somehow, 35 years before the first confirmed interstellar object entered our solar system, he wrote their story. Not the details, not the specific measurements and spectroscopic signatures, but the essential narrative. A massive object from the depths of space, artificial in origin, passing through our solar system without stopping, leaving humanity with more questions than answers. Rendezvous with Rama was published in 1973. The story is simple. Astronomers detect an unusual object approaching the solar system. It is large, cylindrical, rotating with a precise period. Humanity sends a spacecraft to intercept it. The crew explores the interior, finding vast empty spaces, mysterious structures, inactive machinery. They realize they are inside a starship, but one so alien that they can barely comprehend its purpose. And then, before they can learn more, Rama accelerates using some unknown propulsion system and leaves, heading back into interstellar space. No communication, no explanation, visit and departure. When Avi mentioned Rama during the interview, Joe immediately recognised the parallel. Clark imagined a cylindrical object tens of kilometres long. 3i Atlas is spherical and smaller, but still massive by asteroid standards. Clark's Rama rotated to create artificial gravity. 3i Atlas rotates with a 16-hour period. Clark's Rama showed no interest in communicating with humanity. 3i Atlas has displayed no signals, no attempts at contact, just its inexplicable behaviour and mysterious properties. The specific geometry differs, cylinder versus sphere, but the underlying concept is identical, an artifact from another civilization, passing through our neighbourhood, following its own incomprehensible agenda, indifferent to our existence. And here is what makes Clark's vision so prescient. He understood that first contact might not look like the movies. It might not involve landing on the White House lawn, or broadcasting messages or engaging in dialogue. It might just be detection, observation, the slow realization that we are looking at something made rather than born. Clark was a scientist before he was a writer. He had a degree in physics and mathematics. He worked on radar during World War II. He proposed geostationary satellites decades before they were technically feasible. He understood orbital mechanics, thermodynamics, the constraints of space travel. When he imagined what an interstellar probe might look like, he was not fantasizing. He was extrapolating from engineering principles. A cylinder makes sense for a rotating habitat because it creates uniform artificial gravity along its inner surface. A sphere makes sense for structural integrity and efficient material usage. Both designs solve the fundamental problems of interstellar travel: protection from radiation, thermal management, stability. Both would appear anomalous compared to natural objects, and both would behave in ways that violated our expectations based on observing comets and asteroids. During the interview, Avi also referenced 2001, A Space Odyssey, another Clark creation made in collaboration with Stanley Kubrick. The monoliths in that story are even more enigmatic than Rama. Perfect black rectangles with dimensions in the ratio 1 to 4 to 9, the squares of the first three integers, clearly artificial, clearly placed deliberately on the moon and orbiting Jupiter, but their purpose remains mysterious even by the film's end. Are they markers, sensors, communication devices, tests? Avi interpreted the monoliths as baby monitors, sensors placed in humanity's nursery to observe our development. An advanced civilization watching us grow, noting when we achieve certain milestones, perhaps deciding whether we are worth contacting or should be left alone. It is a chilling interpretation because it implies judgment. It implies that we are being evaluated according to criteria we do not understand and cannot control. If 3i Atlas is a probe, if it is here observing rather than exploring, then the baby monitor interpretation becomes uncomfortably plausible. We are a young civilization. A few thousand years of recorded history, a few hundred years of science, a few decades of spaceflight. In cosmic terms, we are infants. And maybe 3i Atlas is checking in, recording data, measuring our progress, not interfering, not helping, just watching. This possibility bothers people more than the idea of random exploration. Random exploration is impersonal. A probe happens to pass through, gathers some data about stellar characteristics and planetary compositions, continues on its way. That is fine. That does not challenge our sense of autonomy, but surveillance implies intention. Surveillance implies that someone cares what we do, that our actions have consequences beyond our immediate environment, that we are not as isolated as we thought. Clark understood this psychology. Rama's indifference to humanity is almost insulting. The explorers inside find wonders, but none of those wonders acknowledge their presence. The ship is empty, dormant, following its programmed course without regard for the curious humans poking around inside. And yet, when Rama accelerates and leaves, when it performs a maneuver that demonstrates clear intentionality, the humans realize they were never in control. They were passengers, tolerated observers, irrelevant to Rama's true purpose. 3i Atlas has shown that same indifference. It entered our solar system following its trajectory. It displayed anomalous behavior, but made no attempt to explain itself. It approaches perihelion today, passes close to the sun, and will begin its outbound journey without pausing for our questions. We can observe it, measure it, speculate about it, follows its own logic, serves its own purpose, and we are spectators. The genius of Clarke's writing is that he made the alien truly alien. Not hostile, not friendly, just incomprehensibly other. Rama is not a weapon. It does not attack, but it is also not a gift. It does not share knowledge or offer assistance. It exists on a different plane of concern, pursuing goals we cannot fathom with resources we cannot imagine. If you read Rendezvous with Rama after learning about 3IA-TLAS, the parallels are eerie. Clarke describes how astronomers initially classify Rama as an asteroid, then realize something is wrong. The albedo is wrong, the shape is wrong, the rotation is too perfect. Gradually, reluctantly, they accept that they are looking at something artificial, and that acceptance changes everything. Not because Rama does anything threatening, but because its mere existence proves humanity is not alone and not first. Joe asked Avi whether seeing something like Rama would be frightening or exciting, and Avi's answer was telling. He said finding a partner can change your future for the better, finding an alien partner even more so. This is not the response of someone worried about hostile invasion or existential threat. This is the response of someone who understands that intelligence, wherever it arises, solves problems. And if we can learn from alien intelligence, if we can study their solutions to the challenges of interstellar travel and long-duration survival, we might leapfrog centuries of our own development. But this optimism depends on the aliens cooperating. Rama did not cooperate. It did not open its knowledge to human explorers. It remained opaque, mysterious, useful only as proof that such things are possible. If 3I Atlas is our Rama, if it passes through without revealing its secrets, we gain the knowledge that we are not alone but lose the opportunity to learn from their technology. We are left in the frustrating position of knowing that answers exist but cannot access them. Clarke wrote sequels to Rama. In those later books, humanity encounters Rama again, and slowly begins to understand its purpose. It is a probe, but not just collecting data. It is selecting specimens, sampling life forms from various worlds, preserving them in some vast cosmic arc. The implications are staggering. In Terna, advanced civilizations as curators of biological diversity. Life not as accidental chemistry, but as cultivated resource. I'm not suggesting 3I Atlas is literally collecting samples, but the idea that probes might have purposes beyond simple exploration, that they might be executing long-term strategies we cannot comprehend, that resonates. If you send a probe across interstellar distances, you do not do it casually. You do it with intention, with goals, with a mission profile that makes sense given your values and capabilities. What might those goals be? Mapping the distribution of life, assessing technological development, searching for resources, testing whether young civilizations can detect interstellar artifacts, warning of impending dangers, seeding new worlds with genetic material. The possibilities are endless, and none of them require communication with us. None of them require the probe to be anything other than what 3I Atlas appears to be. An object passing through, exhibiting strange but purposeful behavior, observable but unexplainable. Clarke's vision of first contact as passive detection rather than active engagement might be exactly right. Maybe we will never have a landing, never have a conversation, never receive transmitted wisdom or warnings. Maybe we will just observe probes passing through, decade after decade, century after century, each one slightly different, each one revealing a little more about the civilizations that sent them, and slowly, gradually, we will piece together the reality of the galaxy we inhabit. That is a very different story than Hollywood sells. No dramatic confrontation, no existential crisis, just the slow accumulation of evidence that we are part of something larger, that the universe is populated, that intelligence is common enough that interstellar probes routinely visit stellar systems, that we happen to live in an era when our technology has finally advanced enough to detect them. Avi is essentially arguing that we should read 3I Atlas the way Clarke's characters read Rama, with wonder, with curiosity, with the understanding that we might not get all our questions answered, but that the questions themselves are valuable. Rama forced humanity to confront its assumptions about cosmic isolation. 3I Atlas is doing the same, and whether the scientific community accepts that challenge or continues dismissing anomalies, the object itself remains. Evidence, data. reality. Clarke wrote Rama in the 1970s during the Apollo era, when humanity was first venturing beyond Earth in meaningful ways. He imagined what we might encounter out there, what surprises awaited us. And now, 50 years later, something like Rama has arrived. Not as dramatic, not as easily explored, but carrying the same fundamental message. You're not alone, you're not first. The universe is older and stranger than you imagined, and the sooner you accept that, the sooner you can begin learning what it means. 3i Atlas will leave. It will continue its journey into the outer solar system, and eventually back into interstellar space. In a few years, it will be too faint to observe, too distant to study, and we will be left with our data, our speculations, our unresolved questions. Like the crew of Clarke's starship watching Rama accelerate away, we will wonder what we missed, what we failed to understand, what opportunities slipped through our fingers because we were too cautious or too frightened or too committed to comfortable narratives. Clarke understood something profound about discovery. The most important revelations are often the ones that raise more questions than they answer. Rama does not explain the universe. It deepens the mystery. It proves that there are intelligences out there pursuing incomprehensible goals with unimaginable resources. And that proof, that simple existence proof, changes everything. Even if we learn nothing else, even if every subsequent observation just confirms that we do not understand, the proof alone is enough. 3i-ATLAS is our proof, our Rama, our monolith. Sitting there in our telescopes, reflecting sunlight, shedding nickel, defying explanation. Arthur C. Clarke would have been fascinated. He would have urged investigation. He would have reminded us that science fiction is not about predicting the future, but about preparing our minds for possibilities we have not yet encountered. And sometimes, just sometimes, the future arrives looking exactly like the story predicted. The baby monitor hypothesis. Are we being watched? There is something deeply unsettling about the idea that we are being observed. Not attacked, not contacted, just observed, monitored, recorded. Like specimens in a laboratory, subjects in an playing in a nursery while unseen adults watch from another room. This is the implication of Avi's baby monitor interpretation of Clarke's monoliths. And if we apply that same framework to 3i-ATLAS, the implications become even more disturbing. Avi laid this out during the interview with elegant simplicity. He said, think of humanity as a baby, just a few million years old in evolutionary terms, a few thousand years old as a civilization. We're young, inexperienced, developing. And if there are older civilizations out there, civilizations billions of years more advanced, they might have placed sensors to monitor emerging intelligence, not to interfere, not to guide, just to watch, to see what we become, to determine whether we are worth their attention. The monolith on the moon in 2001 represents this perfectly, buried deliberately waiting to be found. When humans achieve spaceflight, when they land on the moon and start exploring, they trigger the monolith. It sends a signal to Jupiter, alerting whoever placed it that humanity has reached a certain threshold. We have graduated from stone tools to spacefaring. We are interesting now. We merit further observation. But here is the chilling part. Further observation does not mean contact. The humans who find the monolith do not receive a welcome message or instructions or explanations. They just trigger the alert and then have to figure out what it means on their own. The test is not whether you can find the monolith. The test is what you do after finding it. Do you investigate? Do you ignore it? Do you weaponize it? Do you try to understand it, or do you treat it as a threat? 3i Atlas could be performing exactly this function. Not buried on the moon, but passing through our solar system at a time when we finally have instruments capable of detecting interstellar objects. The anti-tail, the nickel emissions, the spherical shape, all the anomalies we have discussed. Maybe they are not malfunctions or random quirks. Maybe they are signals. Deliberate deviations from natural behavior designed to catch the attention of any civilization advanced enough to notice. Think about what that would mean. An intelligence test. Can you detect the anomalies? Can you distinguish artificial from natural? Can you overcome your institutional biases and theoretical preferences to acknowledge what you're seeing? And more importantly, do you investigate seriously? Do you allocate resources? Do you treat this as the potential first contact scenario it is? Or do you dismiss it, attack those who suggest otherwise, and continue pretending you're alone in the universe? If 3-Eye Atlas is a baby monitor, we are failing the test. We detected it. Yes, that is good. We noticed some of the anomalies. Also good. But our response has been dismissal, rationalization, and institutional resistance to investigation. We're acting like the kid who finds something weird in the backyard, shows it to the adults, and gets told to stop making up stories and go back to playing. We are not rising to the challenge. We are retreating into comfort. Joe pushed Avi on this idea, asking what the Watchers would be looking for, and Avi suggested development milestones. When does a civilization achieve spaceflight? When do they develop radio? When do they start detecting exoplanets? When do they notice interstellar visitors? Each milestone indicates capability and curiosity, and maybe at certain thresholds the monitoring intensifies. Maybe 3-Eye Atlas is not the first probe to visit us. Maybe there have been others that we simply could not detect yet. And now that we can detect them, now that we have crossed that threshold, the game changes. This raises a question that nobody wants to ask. How long have we been monitored? Did probes visit during the Roman Empire, during the Bronze Age, during the Ice Age when humans were scattered tribes of hunter-gatherers? Were they watching when we first used fire, first created agriculture, first built cities? And if so, what were they recording? What data were they sending back to whoever built them? The thought is profoundly humbling. Everything humanity has achieved, every war we fought, every empire we built, every scientific discovery we made, maybe it was all observed, recorded, analysed, compared to other young civilizations on other worlds. And we never knew. We went about our business thinking we were alone, thinking our struggles and triumphs mattered only to us, while the whole time we were being watched. But there is another possibility that Avi hinted at. Maybe the watching is benign. Maybe advanced civilizations have learned that interference does more harm than good. You cannot force development. You cannot rush a species through its adolescence. They have to make their own mistakes. So the monitors just watch. They do not help. They do not hinder. They record. And maybe, if we pass enough tests, if we prove ourselves worthy, then contact happens. Real contact. Dialogue. Exchange of knowledge. That would make 3-Eye Atlas a threshold marker. The test that determines whether humanity is ready for the next phase. And right now we are failing. We are showing that we value comfort over truth, consensus over investigation, institutional authority over empirical observation. We are demonstrating exactly the kind of closed-mindedness that might concern an advanced civilization evaluating whether we are worth engaging with. The baby monitor hypothesis also explains the lack of communication. Parents do not explain themselves to infants. They watch. They respond when the baby cries or needs something. But they do not sit down and have a conversation about their parenting philosophy or their long-term goals for the child's development. The baby would not understand. The baby lacks the cognitive framework to process that information. And maybe that is how advanced civilizations view us. Not as equals ready for dialogue, but as children who need to grow up first. This interpretation avoids both the naive optimism of believing aliens will save us and the paranoid pessimism of believing they will destroy us. It suggests a middle path. Observation without interference. Monitoring without contact. Letting us develop naturally while keeping track of our progress. And only when we reach sufficient maturity, only when we prove capable of handling the implications, then communication becomes possible. But maturity requires certain characteristics. Humility, curiosity, courage, the ability to challenge your own assumptions, the willingness to follow evidence even when it leads somewhere uncomfortable. And by those metrics, our current response to 3-Eye Atlas suggests we are not mature. We are defensive, insecure, too attached to our theories, too frightened of paradigm shifts. Avi mentioned during the interview that intelligence agencies understand the importance of monitoring. They place surveillance on potential threats, on developing situations, on anything that might impact national security. And they take anomalies seriously because anomalies often indicate something important. A change in behaviour, a new capability, an emerging threat or opportunity. They do not have the luxury of dismissing data just because it contradicts their preferred narrative. If advanced civilizations operate with similar logic, if they place probes throughout the galaxy to monitor emerging intelligence, then their approach would mirror intelligence agency methodology: silent observation, data collection, anomaly detection, and triggering alerts when something significant happens. Like a species developing the ability to detect interstellar objects, like a species standing at the threshold of becoming truly spacefaring. That threshold is where we are right now. The past decade has seen explosive growth in our ability to detect and characterize objects outside our solar system. We found Oumuamua, we found Borisov, we found 3I Atlas. This is not coincidence. This is capability improvement. Our instruments got better, our observation networks expanded, we started actually looking, and now we are finding things. Strange things, anomalous things, things that do not fit our models. The baby monitor hypothesis suggests this was inevitable. Once you develop sufficient technology, you start seeing the monitors. They were always there. You just could not detect them before. And now that you can, now that the sensors register on your instruments, the question becomes what you do with that information. Do you acknowledge it? Investigate it? Or do you pretend you are still alone? Joe asked whether this monitoring might have a darker purpose. Maybe the watchers are not benign parents. Maybe they are zookeepers. Or farmers. Maybe we are livestock being fattened for harvest, resources being developed for exploitation, a nature preserve maintained for some inscrutable alien purpose. And Avi acknowledged these possibilities but did not dwell on them. His focus was on the scientific opportunity. Regardless of intent, the presence of probes means we can learn from them. We can study their technology, reverse engineer their capabilities, accelerate our own development. But that optimism depends on access. If the probes just pass through, if they remain sealed and silent like Rama, we gain knowledge of their existence but not knowledge of their construction. We know intelligence is out there but cannot learn from it directly. We are stuck inferring capabilities from external observations, like trying to understand how a car works by watching it drive past at highway speed. You can learn something, but not everything, not enough. The baby monitor hypothesis is frustrating because it implies a power dynamic we cannot change. They watch us. We cannot watch them back. They know about us. We barely know they exist. They make decisions about whether and when to contact us. We have no say in the matter. It is profoundly asymmetric, and humans do not like asymmetry. We like to believe we control our destiny, that our choices matter, that we are agents rather than objects. But maybe that is part of the test. Can we handle asymmetry? Can we accept that there are intelligences far beyond ours, operating on timescales and with resources we cannot match, pursuing goals we do not understand? Can we maintain our curiosity and drive despite knowing we are subordinate in the cosmic hierarchy? Or do we retreat into denial, pretend we are still alone, maintain our comfortable illusions of cosmic significance? 3I Atlas is forcing this question. Its anomalies are too numerous to dismiss, its presence too real to ignore, and if it is a baby monitor, if it is here to observe how we respond to detection of interstellar objects, then our current response is damning. We are acting like children who found the baby monitor and decided to hide it rather than ask what it means. The watchers, if they exist, must be disappointed. Or perhaps they expected this. Perhaps this is a known phase in the development of young civilizations. The phase where they can detect a monitoring, but cannot yet accept what detection implies. The phase where institutional inertia overwhelms individual insight. The phase where fear of paradigm shift paralyzes investigation. And perhaps there is another phase coming, the phase where enough anomalies accumulate that denial becomes impossible, where the evidence becomes so overwhelming that even the most conservative institutions must acknowledge it, where we collectively accept that we are being watched and start asking what that means for our future. Today, at perihelion, 3I Atlas is at its closest. The baby monitor, if that is what it is within optimal observation range. We should be gathering every piece of data we can. We should be treating this as the civilizational milestone it potentially represents. But instead, most of the world does not even know it is happening. Most scientists are ignoring it, and those who do pay attention are mostly trying to explain it away. The monitor is watching, recording our response, sending data back across the light years to whoever built it, and the data we are providing suggests we are not ready. Not mature enough, not curious enough, not brave enough. We found the sensor in our nursery, and instead of investigating, we went back to our toys. The test continues, and we are failing. The Lonely Physicist and the Dating Site Solution reframing Fermi's paradox. Picture Los Alamos in 1950. The Manhattan Project is over, the war is over, but the scientists remain, working on nuclear physics, on weapons development, on understanding the fundamental forces that make atoms tick. And during lunch one day, Enrico Fermi sits with Edward Teller and others, discussing something that seems utterly frivolous compared to their serious work. Extraterrestrials, little green men, flying saucers. They agree as physicists that aliens probably exist. The universe is vast. Stars are common. Planets must be common too. Life arose on Earth from chemistry, and chemistry is universal. So life elsewhere seems likely, maybe even common. And if life is common, intelligence might arise multiple times. This is all reasonable, all logical. Then Fermi asks his famous question, where is everybody? If they exist, if they are common, why have we not seen them? Why no radio signals? Why no obvious constructions? Why no visits? The galaxy is old enough that even slow spacecraft could have crossed it multiple times. The numbers suggest we should be swimming in evidence of alien civilizations, yet we see nothing. Silence. Emptiness. Just us. Alone on a small planet wondering if anyone else is out there. Avi's response to this paradox is perfect. He told Joe, imagine I was sitting next to Enrico at that lunch table. I would put my hand on his shoulder. I would say, Enrico, this is a question every lonely person asks. And what you tell a lonely person is, do not be so presumptuous. You're not that attractive. They will not come to you. You need to seek them. You need to go to dating sites. You need to look through your window and search for them. The analogy is brilliant because it reframes the entire paradox. Fermi assumed a passive model. Aliens exist, therefore they should show up. But why should they show up? Why should they care about us? Why should they expend resources visiting every random planet with primitive life? We do not visit every anthill we pass. We do not make, despite crows being intelligent, tool users. We acknowledge their existence and move on unless we have a specific reason to interact. Maybe advanced civilizations operate the same way. They know we are here. They might even be monitoring us. But they see no reason for direct contact. We are not interesting enough, not advanced enough, not relevant to their concerns, so they do not show up for lunch in Los Alamos just because Enrico Fermi wants them to. They continue their own activities, pursue their own goals, and leave us to develop at our own pace. But the deeper insight in Avi's response is about agency. Fermi's question is passive. It assumes aliens should act while we wait. Avi's answer is active. We should act. We should search. We should build telescopes and scan the skies and investigate anomalies and follow up on strange observations. We should be the seekers, not the waited for. Because waiting gets you nowhere. Seeking might actually find something. And this is exactly what Avi has been doing. With Oumuamua, he did not just observe and catalogue it. He investigated deeply. He questioned assumptions. He proposed the artificial hypothesis and followed where the evidence led. With 3i Atlas, he is doing the same. Not waiting for the object to explain itself, not assuming it will conform to our expectations, actually investigating, actually seeking truth rather than comfort. Joe appreciated this reframing. He laughed at the dating site metaphor, but the point underneath the humour is serious. The Fermi paradox is not really a paradox. It is a failure of imagination combined with unrealistic expectations. We expect aliens to behave like humans in movies, showing up dramatically, making themselves obvious, caring about us specifically. But real intelligence, evolved under different conditions with different priorities, might be nothing like that. They might be quiet, deliberate, patient, operating on timescales that make human history look like a brief flicker. And from their perspective, we are the new arrivals. The loud neighbours who just moved in and immediately started wondering why nobody came by to introduce themselves. Well, maybe they are watching from their windows, deciding whether we are worth talking to, waiting to see if we mature into interesting conversation partners or remain noisy and self-absorbed. The dating site metaphor extends further than Avi explicitly stated. On dating sites, you create a profile, you present yourself, You show your interests, your values, your personality, and then you browse others' profiles looking for compatibility. You do not expect everyone to contact you. You do not assume you are universally attractive. You understand it is a two-way process requiring effort from both sides. Humanity is creating its profile right now. Through our radio emissions, our space probes, our atmospheric composition, our light pollution, we are broadcasting information about ourselves to anyone watching. And 3i Atlas might be part of the browsing process, a probe sent to check us out, to gather detailed data, to see if we are interesting enough for further engagement. But just like on dating sites, browsing does not require immediate contact. You can look at profiles without messaging. You can gather information without committing to interaction. This framework explains the silence without requiring pessimistic assumptions like the dark forest hypothesis. That hypothesis suggests civilizations stay silent because the universe is dangerous, because revealing yourself invites destruction, because predators lurk in the darkness waiting for signals. But maybe the universe is not a dark forest. Maybe it is just a normal neighborhood where people mind their own business, where privacy is valued, where you do not intrude on others without good reason. And from that perspective, Fermi's question becomes absurd. It is like moving to a new neighborhood and immediately complaining that nobody knocked on your door to welcome you. Well, maybe they are busy. Maybe they saw you moving in but did not want to interrupt. Maybe they are waiting for you to settle in before introducing themselves. Maybe they are observing your behavior to decide if you're the kind of neighbor they want to engage with. Avi pointed out that Fermi was an experimentalist. A good one. And yet, when faced with the question of extraterrestrial intelligence, he did not build instruments to search for evidence. He just asked the question at lunch and left it there. An experimentalist asking where everybody is should have immediately started designing telescopes to look for them, should have proposed search strategies, should have allocated resources to investigation. But he did not. He just expressed curiosity and moved on. This is the same pattern we see today with 3i Atlas. Scientists express curiosity. They publish papers. They have conferences. But they do not actually allocate serious resources. They do not build dedicated instruments. They do not organize coordinated observation campaigns. They treat it as an interesting puzzle rather than a potential civilization-defining discovery. Curiosity without commitment. Questions without genuine seeking. Avi is different. He committed. He founded the Galileo project specifically to search for technological signatures. He is putting resources behind his convictions. He is not just asking where everybody is. He is building the instruments to find out. He's going to the cosmic dating site and actively browsing instead of sitting home alone wondering why nobody contacts him. Joe asked about the dark forest hypothesis explicitly, and Avi acknowledged it as one possible solution to the paradox. Civilizations stay hidden because visibility is dangerous. But his tone suggested skepticism. The dark forest requires assuming the universe is zero-sum, that resources are scarce enough to fight over, that cooperation never emerges as a stable strategy. Those assumptions might be wrong. Evolution on Earth produced both competition and cooperation. Intelligence requires social behavior, which requires some level of trust and mutual benefit. Maybe that scales to galactic civilizations too. Or maybe the silence is just indifference, not hostility, not fear, just lack of interest. Advanced civilizations might be so focused on their own concerns, their own projects, their own internal development that they have no time for monitoring primitives like us. They are not hiding in the dark forest. They are just busy with things we cannot comprehend, and occasionally they send probes to check on developing worlds. But those probes are automated, minimal effort, the equivalent of setting up a webcam in the nursery rather than hiring a full-time nanny. 3i Atlas could be exactly that. A webcam. Cheap, disposable, sent to our solar system along with millions of others sent to millions of other systems. Not because we are special, but because we are catalogued, noted as a world with potential intelligence, worth checking on periodically, but not worth dedicated attention until we do something that triggers escalated monitoring. This is actually the most humbling possibility. Not that we are alone, not that we are rare and precious, but that we are common and unremarkable. One of countless young civilizations at roughly our stage of development. Interesting enough to monitor, but not interesting enough to contact. and the probes passing through our system are just routine maintenance, checking boxes on some vast cosmic database, recording whether we are still developing or have self-destructed yet. From this perspective, Fermi's question reveals profound narcissism. Whereas everybody assumes everybody should care about us. But why should they? What have we done that merits attention? We discovered fire, invented writing, split the atom, went to the moon. Impressive by our standards. But maybe by galactic standards, these are just expected milestones. Things every civilization achieves if they survive long enough. Nothing special. Nothing that would make advanced aliens drop everything and come visit. So we wait for them to care while they wait for us to become interesting. And the waiting could last thousands of years, or millions, or forever if we stagnate or destroy ourselves. The only way to break the waiting is to actively seek, to build instruments, to investigate anomalies, to follow evidence even when it challenges comfortable narratives, to stop expecting others to solve our loneliness and start solving it ourselves. Avi ended this part of the conversation by emphasizing the romantic nature of Fermi's question. Whereas everybody is not really about aliens. It is about loneliness, about the human need for connection, about wondering if we matter, if anyone else shares this strange experience of consciousness and curiosity, and that is beautiful in its own way. But romance requires action. You do not find love by sitting home hoping someone knocks on your door. You go out, you search, you risk rejection, you put yourself out there. Humanity's finally starting to do that. We are building better telescopes. We are detecting interstellar objects. We are analysing their properties. We are not just asking where everybody is. We are looking. And when we look carefully, without preconceptions, when we investigate anomalies honestly, we might find that they were here all along, passing through, monitoring, waiting for us to notice them, waiting for us to mature enough to ask the right questions. 3i Atlas might be our first genuine answer to Fermi's question. Not a radio signal, not a message, just a probe passing through, displaying anomalies that suggest artificial origin, giving us the opportunity to recognise it for what it is. And whether we recognise it, whether we investigate seriously, whether we overcome our institutional resistance and theoretical prejudices, that determines whether we are ready for the next step. Whether we are ready to stop being lonely and start being part of the cosmic community. The dating site is open. The profiles are visible. We just need the courage to look, and the humility to accept that maybe, just maybe, we are not the most attractive option out there. But that does not mean nobody will ever contact us. It just means we need to work on ourselves first. Become more interesting, more mature, more worth talking to, and in the meantime, we seek, we investigate, we follow the evidence. Because that is what interesting civilizations do. They do not wait passively. They explore actively. If they are lucky and persistent, they find what they are looking for. Negative mass, time machines, and the technologies we cannot imagine. The unlimited future. Near the end of the interview, after covering all the anomalies and controversies surrounding 3i Atlas, Avi shifted gears. He started talking about technologies we do not have yet. Technologies we have barely theorized. Technologies that might seem impossible, but not ruled out by fundamental physics. And this is where the conversation became truly speculative, truly mind-bending, truly relevant to understanding what 3i Atlas might represent. He mentioned negative mass, not antimatter, which annihilates regular matter in bursts of energy. Negative mass. Matter that has negative gravitational properties. Matter that, instead of attracting other matter, repels it. And if such material could exist, if it could be created or found or somehow utilized, the implications are staggering. Because negative mass would give you propulsion without fuel. Repulsive gravity means you could push against space itself, accelerate without reaction mass, travel interstellar distances without carrying impossibly large fuel tanks. Avi said he is working on a paper about this with collaborators at Applied Physics, not science fiction, not idle speculation. Actual theoretical work exploring whether negative mass propulsion could be feasible within known physics, and the answer appears to be maybe. Not definitely, not with current technology, but maybe, under certain conditions, with certain materials or field configurations that we have not discovered yet, but that might exist. Think about what this means for 3i Atlas. if an advanced civilization has cracked negative mass technology, if they can create or manipulate materials with repulsive gravity, they could build probes that travel between stars efficiently. No massive fuel tanks, no light sails requiring enormous surface areas. Just a generator creating negative mass fields, pushing against the fabric of space, accelerating and decelerating at will. The anti-tail phenomenon suddenly makes more sense, not violation of physics we do not understand yet. Radiation pressure pushes particles away from light sources. We know this. We use it in theories of solar sails and comet tails. But what if you could reverse it? What if negative mass allowed you to create attractive radiation pressure, pulling material toward a light source instead of away? Then an anti-tail becomes not mysterious but expected. Not impossible, but engineered. A sign of technology rather than an anomaly of nature. Joe was fascinated by this. He asked about time travel, and Avi confirmed that negative mass could potentially enable closed time-like curves, time machines. Not the Hollywood version with spinning lights and dramatic sound effects, but real manipulation of space-time geometry, warping space in ways that allow travel to your own past. The mathematics works. General relativity permits it. You just need exotic matter with negative energy density, which might be the same thing as negative mass. Now, time travel raises all sorts of paradoxes. The grandfather paradox. If you go back and kill your grandfather, you were never born, so you could not go back. So your grandfather lives, so you were born. Endless loop. But physicists have proposed solutions. The Novikov self-consistency principle suggests that any action you take in the past was always part of history. You cannot change it because you already did it. Closed time-like curves become deterministic. No paradoxes, just complicated causality. But even without solving all the paradoxes, the theoretical possibility of time travel using negative mass means we have to expand our thinking about what 3i Atlas could be. Maybe it's not just travelling through space. Maybe it's travelling through time too. Maybe it came from our future, sent back by humanity or our descendants or whatever we evolve into. Maybe it is monitoring the development of our civilization from multiple temporal vantage points, gathering data about critical junctures in our history. That sounds insane. I know. But it is not ruled out by physics. And if we are considering artificial origins, if we are taking seriously the possibility that 3i Atlas is technology, we cannot limit ourselves to technologies we currently understand. We have to consider technologies that might be possible but that we have not developed yet. Technologies that would seem like magic to us, but are just advanced engineering to whoever built them. Arthur C. Clarke said any sufficiently advanced technology is indistinguishable from magic. That is the framework we need when examining 3i ATLAS. Not what is magic, what looks like magic, what seems impossible, and then asking, is it actually impossible according to fundamental physics, or is it just beyond our current capabilities? The anti-tail looks impossible, but only if you assume standard radiation pressure and normal matter. If you allow for negative mass or field manipulation or technologies we have not conceived, it becomes possible. Difficult, requiring advanced understanding and engineering, but possible. The same applies to the spherical shape, the nickel emissions, the behavioral transitions. Each anomaly, when viewed through the lens of possible but undeveloped technologies, becomes less mysterious. Avi also mentioned artificial general intelligence, superintelligence, that surpasses human cognitive abilities in every domain. And he suggested that such intelligence could help us develop new propulsion methods, new physics, new ways of interacting with the universe. This is both exciting and terrifying. Exciting because it means we might soon have the tools to understand things that currently baffle us. Terrifying because it means we are standing at a threshold where our own creations might exceed us. But from the perspective of 3i Atlas, AI is relevant because any civilization capable of building interstellar probes has probably developed advanced AI. You do not send biological beings on million-year journeys, you send machines, smart machines, machines that can make decisions, adapt to unexpected situations, repair themselves, continue the mission even if contact with home is lost. 3i Atlas, if it is a probe, almost certainly has some form of AI controlling it, observing, analysing, deciding when to activate different systems. The anti-tail might have been an active decision by the probe's AI. The transition to normal tail behaviour might have been another decision. Not random natural processes, but deliberate actions by a system designed to maximise data collection, or test human observation capabilities, or signal its presence without being too obvious. An intelligence, artificial but real, executing a program written billions of years ago by beings we cannot imagine. Joe asked about seeding the universe with life, and Avi acknowledged this as another possibility opened by advanced technology. Panspermia at intentional scale. If you can travel between stars efficiently, if you have resources to spare, why not seed lifeless worlds with microbes or genetic material? Why not spread biology throughout the galaxy, creating more diversity, more opportunities for intelligence to emerge? 3i Atlas could be performing that function, not just observing but distributing, not just monitoring but cultivating. This brings us back to the Mars hypothesis. Avi mentioned during the interview that life might have started on Mars before Earth, that we might all be Martians, descendants of microbes that survived ejection from Mars and landing on Earth. But what if that process was not random? What if a probe deliberately seeded both planets? What if 3i Atlas is part of an ancient network of probes sent throughout the galaxy to distribute life, monitor its development, and report back on which worlds produce intelligence? That scenario makes humans not native to Earth in a deeper sense than simple panspermia. It makes us part of a deliberate project, cosmic agriculture, intelligence as crop, and 3i Atlas as the farmer checking on our progress, deciding whether we are ready for harvest. Not literal harvest, hopefully, but harvest of information, of culture, of whatever it is that advanced civilizations value from young ones. Avi ended this part of the conversation on an optimistic note. He said finding an alien partner could change your future for the better, and he is right. If we could learn from alien technology, if 3i Atlas or future interstellar visitors could teach us about negative mass propulsion, or time manipulation, or any of the countless innovations a billion-year-old civilization would possess, we could leapfrog millennia of development. We could solve problems that currently seem intractable. Climate change, resource scarcity, mortality, all potentially solvable with sufficiently advanced technology. But the optimism requires cooperation from the aliens. It requires them deciding we are worth teaching. And that decision probably depends on how we handle first contact. Do we treat it seriously, investigate thoroughly, show intellectual courage and curiosity? Or do we dismiss, rationalize, and retreat into comfortable denial? Our response to 3i Atlas might be the test that determines whether we get access to the knowledge or remain isolated children playing in our nursery. The technologies we cannot imagine are the most important ones. Not because we need them right now, but because they represent the future. They represent what becomes possible when you survive long enough, avoid self-destruction, continue advancing, negative mass, time travel, artificial superintelligence. These are not fantasy. These are extrapolations of known physics and current technology. Difficult extrapolations requiring breakthroughs we have not achieved, but not impossible, just hard. And if they are possible for us eventually, they are definitely possible for civilizations that had billions of years head start, which means 3i Atlas could be using technologies so advanced, so foreign to our understanding that its behavior seems magical. The anti-tail could be trivial to them, a basic application of principles they mastered eons ago. The spherical shape could be standard engineering, the obvious design for any interstellar probe. The nickel emissions could be degradation of components we would not recognize as technology, even if we could examine them up close. We are ants looking at a computer chip. We can see it. We can measure some properties, but we cannot understand what it does or how it works because we lack the conceptual framework. 3i Atlas is our computer chip, visible, measurable, but fundamentally beyond our current comprehension. And the question is whether we stay ants, building our little colonies and ignoring the impossible artifact in our midst, or whether we evolve, develop new capabilities, and eventually understand what we are seeing. Today, October 29th at perihelion, we have maximum opportunity to gather data, to observe, to measure, to prepare for the day when we might understand what those measurements mean, because that day will come, either through our own development, slowly advancing our physics and engineering until negative mass and time travel become feasible, or through contact with whoever built 3i Atlas, learning from them directly. But the day only comes if we survive, if we avoid destroying ourselves, if we continue developing, if we maintain our curiosity and courage, if we refuse to let fear or institutional inertia stop us from investigating the anomalies right in front of us. 3i Atlas is a message from the possible future, a demonstration that the technologies we can barely imagine are real, are achievable, are waiting for us if we prove worthy of receiving them. The unlimited future is not guaranteed. It is earned through persistence, through intellectual honesty, through willingness to challenge comfortable beliefs, through investment in science and exploration and understanding, and through recognizing that when something impossible appears in your solar system, when anomalies stack up too high to ignore, when the evidence points toward artificial origin, you do not dismiss it. You investigate it. You learn from it. You let it inspire you toward your own impossible achievements. Negative mass might propel 3i Atlas, but curiosity must propel us toward answers, toward truth, toward the unlimited future that awaits if we have the courage to seek it.